Hi everybody, welcome back. We are continuing on with 2.1. I mentioned 5.1. That was because of the last chapter. My apologies. So we're on the second part of 2.1, which is trigonometric ratio, trigonometry. Today we're going to look at angles and standard position. So here's some of the terminology you need to know. Your initial arm will go on the positive x-axis, and your terminal arm will create your angle. So positive x-axis, there's quadrant 1 right here, positive x, positive y. That'll be the initial arm of your angle. The terminal arm will be located in any of the other quadrants, and you can go from the left or the right or up or down, whatever way you want to look at it. And these are some of the ideas of the quadrants that we need to know. So in quadrant 1, Roman numeral I, it's between 0 and 90 degrees. So 0 up to 90 degrees. Okay? Quadrant 2 is between 90 and 180 degrees. Quadrant 3, III, is in the negative quadrant, right? And it's between 180 and 270. And then quadrant 4 is between 270 and 360, which brings you back to where you started. So 360 and 180, they're equivalent, right? There's a name for them, but they are a little later on. So an initial arm is the arm of the angle in standard position that lies on the x-axis. See the diagram, and positive x-axis. Terminal arm is the arm of the angle in standard position that meets the initial arm at the origin. So it's at 0, 0 here, attaches the two arms, and creates an angle. Angle in standard position, rotational angle, that's the position of an angle when its initial arm is on the positive axis and the vertex is at the origin. So it's the initial arm, I call it the initial arm in this case, but the rotational arm. So it's the positive axis and it starts at the origin. Principal angle is the counterclockwise angle between the initial arm and the terminal arm, and has a value between 0 and 360. That's called the principal angle. So those are things that I'll be speaking of in the video, so just you don't have to memorize them, but when you hear me mentioning those angles, that's what I'm speaking of. Okay? Let's look at the first example. It says sketch the angle in standard position 1 through 5. So I found a neat little link, little website that allows you to draw these pretty neat, and that's where I got these pictures from. It's probably better out there, but this is something I've been looking at. It works pretty well. So it's called mathopenref.com. I will post that angle in the classroom so you have it. And here's all you do. It's pretty neat. Start your 0 and you just take the angle and you'll twist it. The little angle that you see there, that's actually the reference angle. We're going to talk about that a little later on. And then you see the angle it's making. So that's the counterclockwise position they were speaking of as I circle through there. You can also go in the clockwise position, which creates negative angles. That's what I'm going to speak of as well. Okay? So the first one there was 135, and there it is. So I can hide the reference angle, so I don't need that right now. So right here, this would be the initial arm. I know you don't see it, but there's the initial arm of a positive x-axis. All right? And then the terminal arm, here's the blue line, and that's the angle it creates. So it's in quadrant 2, 135 degrees, and that's what I have for helps. And then 210, same idea. So 210, I'll grab my angle, and again, there's a little dot you can see. You just put the hand there and put it down until you get to 210. There you go. And if we want the reference angle, just hit show. Pretty neat. I'm sure there's other stuff this can do. This is just what I've been using. Okay? And I'll post that link when we start chapter 2. Let's go back to our next example. This is the negative, and then you'll notice that this time we're getting a red angle. Just black is positive and then red is negative. So anytime we do negative, we start at the same initial arm, but you go in a clockwise position instead, so that's why it's negative. So I'll start this back at 0, and then I'll go in the clockwise position to 320, so there's 180, 270, oh, way back, and there's 320. Okay? So the reference angle would be 40 degrees there. As you can see. Okay? Once we explore these things, a lot of this will make sense. Well, we're just drawing the angles at this point. In 270, it's directly on the negative y-axis. I'll show you that. So back that around to 270, right there. So remember, your 0, 90, 180, 270, back to 360 will always be on the x and y-axis, right? So 0 and 360s, and every multiple of 360, so 360, 720, 1080, and so on, they will all be, because you get 360 all the way around, 720, keep adding, right? 1080. Okay? And we do a little bit more of that later on. Okay? So, neat little program. You can just grab the angle and switch. I like it for an online tool for drawing. Let's look at what a reference angle is. I showed you that before. It says reference angle is the acute angle whose vertex is the origin and whose arm, or the terminal arm of the angle and the x-axis. So the reference angle is on the x-axis. So it doesn't have to be positive. So the reference angle will always be between 0 and 90 degrees. I should have said that there. Okay? So I'll show you what I mean here in a minute. Alright? And there's how we calculate it, but I'm going to bring up my program. So if I hit show, it gives me the reference angle. So you'll notice that the reference angle, regardless of which way I'm going, is always between 0 and 90. So if I had 230 like they gave us before, a new page, 230, their angle is 15. So quadrant 3, we take 230, subtract 180 from it to get the reference angle. So 230 subtract 180, that gives us the reference angle. So that's how you calculate the reference angle in each quadrant, where you have, again, your angles have to be in standard position of 0 to 360. When you get in the negative, it's a little different, but that's how they're calculated. So sketch the angle in standard position and find the reference angle. So the first one's 75. You'll notice that 75, the reference angle is also 75 because it's in quadrant 1. It'll always happen in quadrant 1 for anything between 0 and 90. Okay? And then the next one we have is 280. And again, the reference angle for the first quadrant is just is equal to theta. Alright? Reference angle is equal to theta. Okay? So in quadrant 2 it's 180 minus theta. In quadrant 3 it's theta minus 180. And in quadrant 4 it's 360 minus the angle that you're given. Again, that's when these are between 0 and 360. Okay? So let's take our drawing up again. The next one was 282, I think. Yeah, 282. So let's take a look. We'll click on our program. So 282, we know quadrant 2 is 0 to 90, or sorry, 90 to 180. Quadrant 3 is 180 to 270. So we know we're going to go slightly more than that. 282, our reference angle is 78. And we can show that calculation. 360 minus 282 would equal to 78. There's your reference angle. Okay. You see a little star by 118. 118 is a little different. Your reference angle is going to be 62. Again, there's no calculation per se for that. Just draw your angle, right? So negative 118 will go in the opposite direction, negative 90, negative 118, and then we can take the angle and look at it using program 62. Just basically drop your initial arm on either the negative x-axis or the positive x-axis, and you create an angle of 60. Pretty easy. A lot of you can do it intuitively in your head. 150 is in quadrant 2. I'll show that other one there, the negative 150. Still 150 this time. Go back to the positive. 150. A lot of you probably know right now it's going to be 30. And you'll be right. Okay? And when we start doing some of these calculations from the sine, cos, and tan, it'll make a lot of sense of this, of why this different. When you take the function of sine, cos, or tan of a particular angle, well, sine and cos will be most of it, that you will get the same answer for different angles. This really shows that. Why they're equivalent. It's pretty neat. 180 is right on the line. We know the reference angle would be 0. Take a look. So 180, you get closer and closer. The reason is that the terminal arm and the initial arm are the same, right? Essentially the same, so the reference angle is 0. Okay. And 270 is the same idea. I just want to show that one as well. So if ever program 270s, we keep going on to 90. It's 90 degrees. Because you got your 180 to here, bring your 270 down here, so to make the reference angle is with the negative x-axis, so it'd be 90 degrees. I think I'll end the video here, and then we'll pick up on page 9 with the reference angles as well. Okay? And then I think we'll go to this page. We got 3 more minutes left. Given the following reference angle in the quadrant, sketch the angle and give the principal angle. Right? So the principal angle is basically going the opposite direction we did before. Right? So reference angle of 28 in quadrant 1, we know that would equal the principal angle is also 28. So 47 in quadrant 2. What we need to do is we rearrange the formula so theta is now 180 minus the reference angle, which will give us 133. Right? Or you can use your program too to help you with that. So we got quadrant 2 of 47. So there's quadrant 2 right here, 47, so that means our principal angle is 133. So reference angle is between 0 and 90, and your principal angle is what you add or subtract, or whatever the case may be, to get the principal angle. Okay? Quadrant 3 of 18 degrees. So quadrant 3 of 18 degrees would be slightly down past the 180, so it's 180 plus the 18, and that'll give you 198. Quadrant 4 of 70, so 70 would be here, down there, so we take the 360 and subtract the 70, and that'll give us the principal angle back at 190. Okay? 90 degrees between quadrant 3 and 4. So that would give us a principal angle of 270, I think. I have these two diagrams interchanged. I will fix that. I do apologize. So these diagrams will be changed. Sorry about that, folks. I just fixed the 2 screens there. I just had these interchanged. So I just swapped these. So 90 degrees between quadrant 3 and 4 would be there's quadrant 3, there's quadrant 4, there's 90 degrees in between. So that means our principal angle would be 270. And 0 degrees between quadrant 2 and 3, there's quadrant 2, there's quadrant 3, and 0 degrees in between 2. So obviously principal angle is. Okay? Alright, some worthwhile tasks to try from the textbook would be on page 83, numbers 1 through 7, 11, and 13. Do your best to complete them. You don't have to complete them all. There's also extra practice section with these as well. So we'll see everybody in section 2.2.